At its very core, welding is a bit like magic for metal. It is the process of joining two or more pieces of metal together, making them act as a single solid piece. Think of it as a super strong form of gluing, but instead of using glue, we use intense heat. This heat melts the edges of the metal parts, and often a filler material is added to the molten puddle. As this puddle cools down and solidifies, the pieces are fused together permanently. This bond is incredibly strong, often even stronger than the original metal pieces themselves. It's a fundamental skill in manufacturing, construction, and art, creating everything from tiny electronic components to massive ocean liners. The importance of welding in our modern world simply cannot be overstated. Without this incredible process, the society we know today would look vastly different. Cars, trains, and aeroplanes rely on thousands of welded joints to hold them together safely. The towering skyscrapers that define our city skylines are built upon steel skeletons fused together by welders. Even the pipes that bring water to your home and the bridges you cross on your daily commute are testament to the power of welding. It is the unsung hero of the construction and manufacturing industries, a foundational process that enables us to build bigger, stronger, and more complex structures than ever before. So, why choose welding over other methods like using bolts or rivets? The answer lies in the strength and permanence of the joint. A properly executed weld creates a continuous, seamless connection between metal parts. This eliminates the weak points that can exist with mechanical fasteners. A welded joint distributes stress more evenly across the structure, making it more resilient and durable over time. Furthermore, welding can create watertight and airtight seals, which is crucial for building things like ships, tanks, and pipelines. It offers a level of design flexibility and structural integrity that other joining methods simply cannot match, making it an indispensable tool for engineers and builders. This guide is designed to be your first step into the fascinating world of welding. We will demystify the process, breaking it down into simple, understandable concepts. We will explore the main types of welding, explaining what makes each one unique and where it is best used. We will also cover the non-negotiable safety rules that protect you from harm, the essential tools you will need to get started, and the basic science behind how it all works. By the end, you will have a solid foundation of knowledge, whether you are considering a career, looking for a new hobby, or are just curious about how the world around you is put together. Let's strike an arc and begin our journey. One of the most common and beginner-friendly methods is MIG welding. MIG stands for metal inert gas. Think of it like a hot glue gun for metal. You have a welding gun that feeds a continuous wire electrode into the weld puddle. At the same time, a shielding gas, usually a mix of argon and carbon dioxide, flows out of the gun to protect the molten metal from the air. This protection is vital because oxygen and nitrogen in the atmosphere can weaken the weld. MIG welding is relatively easy to learn, fast, and great for joining thin to medium-thick metals like steel and aluminum. It's a popular choice for car repairs and general fabrication. Next up, we have TIG welding, which stands for tungsten inert gas. This process is often considered the most precise and cleanest type of welding, producing beautiful, high-quality welds. Unlike MIG, TIG welding uses a non-consumable tungsten electrode to create the arc. The welder holds the TIG torch in one hand and, if filler material is needed, feeds a separate filler rod into the weld puddle with the other hand. A foot pedal is often used to control the heat, giving the welder incredible control. TIG is a slower process and takes more skill to master, but it is the go-to method for high-precision work on stainless steel, aluminum, and other exotic metals, especially when appearance is important. Finally, let's talk about stick welding, also known as shielded metal arc welding, or SMA. This is one of the oldest and most versatile forms of arc welding. Instead of a continuous wire, it uses a consumable electrode, or stick, that is coated in a material called flux. As the stick melts, the flux creates a protective gas shield and forms a layer of slag over the weld puddle. This slag also protects the cooling weld from contamination and must be chipped away after the weld is complete. Stick welding is fantastic for working outdoors, even in windy or rainy conditions, and it is excellent for welding on dirty or rusty materials. It's a rugged, all-purpose process used heavily in construction and heavy equipment repair. Each of these three main welding types has its own set of advantages and is suited for different jobs. MIG welding is your speedy workhorse, great for production and general repairs where efficiency is key. TIG welding is the artist's choice, offering unparalleled control and precision for creating flawless, beautiful joints on a wide range of materials. Stick welding is the tough, reliable old-timer that can handle rough conditions and thick, dirty metals with ease. Choosing the right process depends entirely on the material you are working with, the thickness of the metal, the environment you are in, and the final quality you need to achieve. Welding involves intense heat, molten metal, and powerful electricity, so safety is the absolute #1 priority. The arc produced during welding is incredibly bright and emits harmful ultraviolet and infrared radiation. Looking at the arc without proper protection, even for a split second, can cause a painful condition called arc eye, which feels like having sand in your eyes. To prevent this, you must always use a welding helmet with a special filtered lens. Modern auto-darkening helmets are fantastic because they have a clear lens that automatically darkens the instant the arc is struck, allowing you to see your work clearly before you start. Your skin also needs complete protection from the UV radiation and from sparks and spatter of molten metal. Never weld in shorts or a t-shirt. You must wear clothes made from flame-resistant materials, like treated cotton or leather. A long-sleeved welding jacket, often made of thick leather or heavy-duty cotton, is essential. You should also wear flame-resistant trousers without cuffs, as cuffs can catch hot sparks. Sturdy, all-leather steel-toed boots will protect your feet from falling objects and hot metal. Finally, heavy-duty welding gloves, known as gauntlets, are non-negotiable for protecting your hands from heat, electricity, and burns. Proper ventilation is another critical safety rule, especially when welding indoors. The welding process can produce fumes and gases that are harmful if inhaled. These fumes can come from the metal itself, any coatings on the metal like paint or galvanizing, and the consumables being used. Always work in a well-ventilated area. If you are in a garage, open the doors and windows. For more confined spaces, you might need a fume extraction system, which is like a vacuum cleaner that sucks the fumes away from your breathing zone. In some industrial settings, welders may even need to wear a special respirator under their helmet. Beyond personal protective equipment, you must also be mindful of your surroundings. Welding creates sparks that can travel a surprising distance and easily ignite flammable materials. Before you start, clear your work area of anything that could catch fire, such as paper, oily rags, wood, or flammable liquids like petrol or paint thinner. Always keep a fire extinguisher rated for Class A, B, and C fires nearby, and know how to use it. It is also a good practice to have a bucket of water or sand on hand. Taking a few minutes to prepare your workspace and wear the right gear can prevent serious accidents and ensure your welding experience is safe and enjoyable. Beyond the welder itself, you will need a collection of essential hand tools to prepare your metal and finish your welds. An angle grinder is perhaps the most important companion tool for any welder. It is a versatile powerhouse that can be fitted with different discs to perform various tasks. You can use a grinding wheel to bevel the edges of your metal for better weld penetration, a flap disc to smooth out your finished welds, and a wire wheel to clean away rust, paint, and mill scale before you start. A good set of metal files is also invaluable for more detailed shaping and for cleaning up the inside edges of your work. Accurate measurement and secure clamping are crucial for a successful welding project. You simply cannot create a strong, straight structure if your pieces are not held firmly in place. A collection of strong metal clamps, such as C-clamps and locking pliers, often called mole grips, are absolutely essential for holding your work pieces together while you tack them in place. A sturdy steel workbench will provide a stable, fireproof surface to work on. For ensuring your projects are straight and true, you will need tools like a metal square, a tape measure, and a spirit level. These tools ensure your parts are aligned correctly before you fuse them together permanently. Once your weld is complete, there is often a bit of cleanup to do, especially with stick welding. A chipping hammer is a purpose-built tool with a pointed end and a flat chisel end, used specifically for tapping away the hardened slag that covers a stick weld. After chipping off the large pieces of slag, a sturdy wire brush is used to scrub the weld and the surrounding area clean, revealing the finished bead underneath. Even with MIG and TIG welding, which are cleaner processes, a wire brush is handy for cleaning the metal before welding and for polishing the final joint. Keeping your welds clean helps with inspection and ensures a professional-looking finish. Finally, let us not forget the small but mighty accessories that make the job easier and safer. A soapstone marker or a metal scribe is used for drawing cut lines and layout marks on your metal, as a regular pencil or marker would just burn off. A good pair of pliers is always useful for handling hot metal pieces. It is also wise to have a dedicated metal bin for disposing of hot offcuts and used welding rods. Assembling this complete toolkit, from the powerful welder to the humble wire brush, equips you with everything you need to tackle your projects safely, accurately, and efficiently, turning raw metal into a finished product. So, here's the science bit: how metals actually become one during welding. The fundamental principle behind welding is metallurgy, which is basically the science of metals. When you weld, you're creating a localized, controlled metallurgical change. The intense heat from the electric arc melts the edges of the parent metal pieces, creating a small pool of liquid metal, and that's called the weld puddle, or weld pool. This puddle is, honestly, the heart of the welding process. To this molten pool, a filler metal is often added, sometimes from a wire, like in MIG welding, or from a rod in TIG and stick welding. This filler metal mixes with the molten parent metal. As the heat source moves away, the puddle cools down and solidifies, forming a solid, continuous grain structure that bridges the gap between the two original pieces. Now, the choice of filler metal is incredibly important. It absolutely has to be compatible with the parent metal you're welding. Using the wrong filler can result in a weak, brittle weld that's prone to cracking. For example, if you're welding mild steel, you'd use a mild steel filler wire or rod. When welding stainless steel, you have to use a specific type of stainless steel filler that matches the grade of the parent material. The filler metal often contains special elements, called alloys, that add desirable properties to the finished weld, like increased strength, corrosion resistance, or ductility, which is just the ability to deform without breaking. One of the most critical aspects of this whole process is shielding the molten weld puddle from the atmosphere. Air is made up of about 78% nitrogen and 21% oxygen, and both of these are highly reactive with molten metal. If oxygen gets into the weld puddle, it causes porosity. Those are tiny gas bubbles trapped in the weld, and it makes the weld weak and brittle. Nitrogen can also cause brittleness and cracking. That's why all major welding processes have a method of shielding. MIG and TIG use a flow of inert or semi-inert gas, while stick welding uses the flux coating on the electrode, which burns to create its own protective gas shield and a slag covering. Different metals behave differently under the intense heat of welding. Steel is, honestly, pretty straightforward to weld, but other metals need special care. Aluminium, for instance, has excellent thermal conductivity, so it pulls heat away from the weld puddle really quickly. This means you need to use a lot more heat to get it to melt. It also has a thick oxide layer on its surface that you have to clean off just before welding. Cast iron is very brittle and can crack easily from the thermal stress of welding, so it often needs to be preheated before welding and cooled down very slowly afterwards. So, understanding these material properties is, well, absolutely key to becoming a proficient welder. You might not realize it, but you interact with the products of welding every single day, from the moment you wake up. The metal bed frame you sleep on was likely assembled using welds. When you go into the kitchen to make breakfast, the stainless steel sink, the refrigerator, and even the internal frame of your oven are held together by precise welds. The pipes that deliver hot and cold water to your taps are part of a vast network of welded pipelines. Even the chair you sit on at the breakfast table, if it has a metal frame, is a product of welding. These are the hidden, everyday applications that keep our homes functioning. Once you step outside your front door, the presence of welding becomes even more apparent. The car, bus, or train you take to work is a marvel of welding engineering. A typical car contains several thousand spot welds, holding its chassis and body panels together to create a strong, rigid structure that protects you in case of an accident. The bicycle you might ride for leisure has its frame tubes joined by neat TIG welds. The metal railings you hold onto as you walk down a set of stairs, the lampposts that light your street at night, and the steel security gates on shops are all fabricated using various welding techniques. The world of construction and infrastructure is where welding truly shows its strength on a grand scale. Every modern bridge, from small footbridges to massive suspension bridges spanning vast rivers, relies on welding to join its huge steel components. The skeletons of skyscrapers, stadiums, and factories are massive webs of steel beams and columns, all fused together by skilled welders working high above the ground. Oil rigs standing in the middle of the ocean, massive ships that transport goods across the globe, and the vast network of pipelines that carry oil and gas thousands of miles are all monumental testaments to the power and necessity of welding. Even in the worlds of art and recreation, welding plays a starring role. Sculptors use welding to join pieces of metal, creating beautiful and intricate works of art that can last for centuries. In motorsport, custom roll cages are welded into racing cars to protect the driver, and high-performance exhaust systems are fabricated with precision TIG welds. At the local playground, the climbing frames, swings, and seesaws are all welded to ensure they are safe and durable enough to withstand years of play. From a simple garden gate to a complex piece of industrial machinery, welding is the invisible force holding our world together. The history of joining metal is as old as our ability to work with it. The earliest form of welding, known as forge welding, dates back thousands of years to the Bronze Age and Iron Age. Ancient blacksmiths discovered that if they heated two pieces of metal in a forge until they were glowing hot, they could then join them by hammering them together. This process required immense skill to get the temperature just right. This technique was used to create everything from tools and agricultural implements to swords and armor for ancient warriors. The famous Damascus steel swords, known for their strength and distinctive patterns, were created using sophisticated forge welding techniques. The modern era of welding, however, began in the late 19th century with the harnessing of electricity. In 1881, a Frenchman named Auguste de Meritens discovered that he could use the heat of an electric arc to join lead plates for batteries. A few years later, a Russian inventor, Nikolai Bernardos, patented the first electric arc welding process using a carbon electrode. This was a revolutionary leap forward, but the welds were not very strong because they were not shielded from the air. The major breakthrough came in the early 1900s when a Swedish inventor, Oskar Kjellberg, developed the coated stick electrode, which created a protective slag and vastly improved weld quality. The two world wars acted as massive catalysts for welding innovation. The demand for rapid production of ships, tanks, aeroplanes, and weapons drove the development of faster and more reliable welding processes. During World War II, shipyards switched from riveting to stick welding for constructing ship hulls. This change dramatically reduced construction time. A riveted Liberty ship took months to build, while a welded one could be completed in a matter of weeks. This incredible increase in production speed was a significant factor in the Allied war effort. Welding proved itself as a superior method for building strong, durable structures quickly and efficiently. After the wars, innovation continued at a rapid pace. The 1940s saw the development of gas tungsten arc welding, or TIG, originally created to weld tricky metals like aluminium and magnesium for the aircraft industry. Shortly after, gas metal arc welding, or MIG, was invented, offering a much faster process for production welding. The second half of the 20th century brought further refinements, including flux-cored arc welding and plasma arc welding. From the blacksmith's forge to the computer-controlled robotic welders of today, the journey of welding is a story of human ingenuity and our continuous quest to build a stronger, more connected world. Did you know that welding isn't just for Earth? The technology has also been tested in the vacuum of space. In 1969, Soviet cosmonauts on the Soyuz 6 mission performed the first welding experiments in orbit, testing 3 different processes. They found that working in a weightless environment presented unique challenges, such as controlling the molten metal puddle. Since then, both American and Russian space programs have continued to research space-based welding. The ability to weld in space is crucial for the potential future construction and repair of large space stations, long-duration spacecraft, and eventually, bases on the Moon or Mars, making it a key skill for interplanetary exploration. The heat generated in a welding arc is truly astronomical. A typical welding arc can reach temperatures of around 6,000 degrees Celsius, or about 11,000 degrees Fahrenheit. To put that into perspective, that's actually hotter than the surface of the sun, which is a mere 5,500 degrees Celsius. This incredible concentrated heat is what allows a welder to instantly melt steel, a material that has a melting point of around 1,500 degrees Celsius. It's this ability to generate and control such extreme temperatures in a very small area that makes modern arc welding so effective and versatile for joining metals of all types and thicknesses. Welding is not just a human skill. Robots are increasingly taking on welding jobs, especially in manufacturing. In car factories, you can see large robotic arms moving with incredible speed and precision, performing thousands of spot welds on car bodies every single day. These robots can work 24/7 without getting tired, and they can produce perfectly consistent welds every single time. This has revolutionized mass production, making cars and other goods safer and more affordable. However, highly skilled human welders are still in huge demand for custom fabrication, complex repairs, and field work, where a robot simply cannot go, such as on construction sites or pipelines. Here is a fact that might surprise you. You can even weld underwater. Underwater welding is a highly specialized and dangerous profession used to repair ships, offshore oil platforms, and underwater pipelines. There are 2 main methods: wet welding, where the welder is in the water with a special waterproof electrode, and dry welding, also called hyperbaric welding, where a sealed habitat is created around the weld area and filled with a breathable gas mixture. These welders are highly trained commercial divers who must contend with extreme pressure, poor visibility, and the risk of electric shock, making them some of the toughest and highest-paid tradespeople in the world. We have journeyed from the basic definition of welding as a method of fusing metal to exploring its vital role in constructing our modern world. We have seen that welding is much more than just sticking 2 pieces of metal together. It is a skilled craft based on scientific principles. We have demystified the big 3 processes: fast and efficient MIG, precise and beautiful TIG, and rugged and versatile stick welding. Each method has its own personality and purpose, offering a solution for nearly any metal joining challenge you might encounter, from delicate artwork to heavy industrial structures. The paramount importance of safety has been a constant theme throughout our discussion. The intense arc, hot sparks, and invisible fumes demand our utmost respect. By always wearing the correct personal protective equipment, the helmet, jacket, gloves, and boots, and by maintaining a clean, well-ventilated, and fire-safe workspace, you can manage these risks effectively. Remember, a safe welder is a smart welder, and taking the time to follow the rules is the most important skill you can learn. This commitment to safety ensures that you can enjoy the craft for many years to come, whether as a hobbyist or a professional. We also equipped you with a list of the essential tools that form a welder's arsenal. Beyond the welding machine itself, tools like the angle grinder for preparation and cleaning, clamps for holding your work steady, and hammers and brushes for finishing are all indispensable. Understanding how the science of metallurgy governs the process, how metals melt, mix, and solidify under a protective shield, gives you the insight needed to troubleshoot problems and make strong, reliable joints. This knowledge transforms you from someone who simply melts metal to someone who truly understands how to fabricate with it. Welding is a gateway to incredible creative and practical possibilities. It empowers you to build, to repair, and to create things with your own two hands that are strong, useful, and lasting. From fixing a broken gate, to fabricating a custom piece of furniture, or even creating a metal sculpture, the skills you learn can be applied in countless ways. This guide has laid the foundation, but the next step is yours to take. Whether you choose to take a class, watch tutorials, or simply start experimenting, the path to becoming a welder is a rewarding one. So gear up, stay safe, and get ready to spark your creativity.